geometric and number patterns. My prop box begins with an internet interactive mathematical game, which will engage the students into the concept of number patterns. Due to this, I would use this activity at the beginning stages of teaching this topic. This utilises technology, or ICT, and attends to the needs of students who learn both visually and kinesthetically. Children love playing computer games, so by using these websites, students will be engaged in mathematical content while having fun and forgetting they are learning as such. This game is really beneficial for children, as they can begin the game slowly, and as their learning and confidence increases, they can move through their game quicker. The game can be used for both stages 2 and 3.
Great job!
This balloon pop game, as you have just seen, can be utilised as assessment as learning in the classroom for students to create a challenge against themselves to better their results. Each time they replay the game, lessening their mistakes and quickening the time it took to complete the activity. This activity can also be utilised by teachers, as Thoreau, Cunningham and Moe explain. This use of assessment can be used to gather information to guide the curriculum planning that influences future student learning. In the 21st century, technology greatly benefits the mathematical classroom. It is a powerful tool that can greatly enhance the teaching and learning process. Thompson, 2008. Technology has further beneficial attributes, as the teacher can write by hand on the computer screen, which can be stored on a computer and retrieved. Technology is also used to bring a variety of computer resources into the classroom, including simulations, videos, digital textbooks, internet, and games. Thompson, 2008. The correct syllabus documents and details, such as MA2 to WN, including selects and uses appropriate mental or written strategies or technology to solve problems, will be used or placed within my prop box, so I, the teacher, have a clear understanding of what I should be teaching my students and where their learning should develop. The syllabus provides a clear sequence structure to centre my teaching around. The main working mathematically syllabus outcomes that will be achieved is using appropriate terminology to describe and symbols to represent mathematical ideas for stage 2, and for stage 3 describes and represents mathematical situations in a variety of ways using mathematical terminology and some conventions, and also selects and uses appropriate mental or written strategies or terminology to solve problems, and for stage 3 selects and applies appropriate problem-solving strategies, including the use of digital technologies in understanding investigations. The algebra outcomes that my activities will focus around are: for stage 2, uses mental and written strategies for addition and subtraction involving 2, 3, 4 and 5 digit numbers, and for stage 3 selects and applies appropriate strategies for addition and subtraction with counting numbers of any size, and also generalizes properties of odd and even numbers, generates number patterns and complete simple number sentences by calculating missing values, and for stage 3 analyzes and creates geometric and number patterns, constructs and completes number sentence, and locates points on the Cartesian plane. Personally, I think to successfully teach geometric and number patterns, a lot of hands-on activities should be included to keep students focused and engaged in the concept. This concept can be hard to grasp, so if the activities are enjoyable, the students will learn much quicker and easier. The next activity in my prop box is a matchsticks activity. I asked a few friends and my housemates to think back to primary school and remember what their teachers used to teach patterns to their class, and a recurring activity was the matchstick activity. This activity allows students to create patterns of regular and irregular shapes, discuss the pattern and number of sticks used in a pair or small groups, and analyse what is happening or occurring. This is a hands-on activity which incorporates concrete materials, which can be transferred to a pictorial to abstract by drawing their data in a table. The importance here with concrete, pictorial and abstract is that students are starting with the concrete materials, the matchsticks, then they move to pictorial and draw a representation of the pattern they made. And from this, they present their data into a table representation. This can be drawn or created using a computer, which incorporates technology into this activity. As explained on page 170 of the prescribed text, it is important for students to understand the difference between repeating and growing patterns. Experience with growing patterns leads to a functional thinking mind frame. So this is a screenshot of the Enrich Matchsticks activity, which I've adapted to create my own activity, where students use matchsticks and create patterns using these matchsticks. This is a fun and inexpensive way of incorporating concrete materials into the mathematical classroom. Students are required to make a square, count the amount of matchsticks used. Students then make 2 squares and count the sticks used. This continues on until the students can understand the pattern occurring. Students then create a pictorial representation of their pattern, then present their analysis and data as a table. My next activity incorporates concrete material, pictorial and abstract as well, including M&Ms. M&Ms are a fun and tasty way to introduce mathematics to children, providing children don't have any allergies, otherwise this activity can be completed using another type of lolly, food or counters. Before students are allowed to eat the M&Ms, they are to draw a representation of 2 or more of their repeating patterns in a pictorial representation. Siro, Callingham and Moore explain repeating patterns as when students are working with repeating patterns, the focus is identifying regularity and extending the pattern. Of a student's work that they might do. So you have the M&Ms going across with grey, blue, and then as they advance with their learning, they will be able to answer the question and say the next 2 M&Ms would be grey, then blue. I know this because the repeating pattern is grey, blue, or 1, 2, 1, 2, 1, 2. This activity can also incorporate growing patterns, as students are required to be exposed to growing patterns and need to understand the difference between growing and repeating patterns, which helps them to develop a multiplicative thinking mind frame. The idea with this activity is to ask students to guess or predict what the next element of the pattern will be. This is an example of using growing patterns with M&Ms. Here we can see how a student would use the M&M growing pattern in a pictorial representation and an abstract representation. Different coloured or shaped beads can be used to thread onto a piece of string to examine the types of patterns that can be made. Students can create their own pattern, which includes hands-on activities with concrete materials. This activity can also be completed with different types of pasta or different coloured pasta. And another concrete material often used for discovering patterns is using shells or rocks of the same shape or colour. As a class in EDME369, we were reintroduced to pattern-shaped blocks during one of our tutorials. Even as a 22-year-old, I found this activity engaging, and so did several classmates. We were required to make a pattern and describe the pattern to our classmate without them seeing the pattern. This activity requires students to think on 2 levels. The first, just labelling the colour, yellow, red, and the second level is remembering the shape's name, such as square, triangle, square, triangle. This activity can be used for teachers to assess, assessment for learning, to provide information on students' achievement and progress and set the direction for ongoing teaching and learning. This activity can also be used as concrete, beginning with the blocks, pictorial, creating a pictorial representation of their pattern, and abstract by presenting their data in a table. This is either hand drawn or again using a computer to incorporate technology into the activity. Then this can be printed off for the teacher to use as a form of assessment. A repeating pattern has a core element that is repeated over and over. One of the simplest repeating patterns has an alternating pattern, such as the following, as you can see here. The colour, red, yellow, or the shape, triangle, square, square. My next activity is number charts, or hundreds charts. Now there are many ways this activity can be adapted. The most basic way is printed worksheets. This activity assists students with counting and place value or to identify patterns in a number sequence. However, Thomas and Mullingham, as cited in Siro, Callingham and Muir, states many children tend to represent the numbers 1 to 100 in unconventional ways. This can be done on many different levels. Hundreds charts can be printed on paper for students to highlight, circle or colour in pattern numbers. Students can put counters on top of numbers within the hundreds chart. This is a more hands-on approach to teaching number patterns. The next type is students can use a computer to play games associated with hundreds charts, or a hundreds chart could be drawn in chalk in a large concrete area for children to see patterns off the paper and outside the classroom. Students can stand on numbers to create patterns and understand number patterns from a larger scale. MathLab provides printable worksheets and puzzles or games students can work with hundreds charts. Music can be used for students to grasp an understanding of patterns. This can be as simple as clapping a pattern and having the class clap the pattern back to you. Then students break into pairs and continue to make patterns for each other. This can also be used as a classroom management tool for gaining student attention, but while gaining attention is reinforcing the concept of patterns to the class each time the tool is performed. Claire and myself are now going to demonstrate how children can understand patterns through clapping. No, you do. My next lot of activities within my prop box are to do with students getting outside of the classroom. So the first activity is a PE activity which links exercise with mathematics. Students work in groups to make a pattern using their bodies. The rest of the class has to guess what the pattern is until all students have had a go. Students are sent out into the school in pairs to find patterns within the school. Some examples include students looking at monkey bars and what the patterns are occurring there. They look at brickwork or the structures of buildings in the schools, or even plants and patterns on the leaves, petals, branches or more. Students have to draw a pictorial representation of at least 3 patterns they discover and be able to discuss this to their class and the recurring pattern that they've found. I tried to think outside the box for this assignment and actually found research to back up my physical activities. This incorporates movement into the activity. Physical activity or movement is extremely beneficial when it comes to learning or studying. This is something that many researchers have studied or proven. Haraska and Clancy are 2 that have worked to prove this, as in addition to its purely physical advantages, movement has long been recognised for its value in the development of cognitive skills in young children and for supporting learning. Movement can provide one means for practicing the acquisition of new information and formation of memories, and when performed with this information, allows cognitive information to be linked with movement. As a part of the memory, movement then can be used to help recall that memory. Hannaford, 1995. Once the physical side of it is completed, the students are to represent their data in an abstract form of using their data in a table. Lancaster discusses in his video the benefits of taking a mathematical class out into the playground for a lesson. He discusses the value as students see mathematics in their surroundings. This allows students to understand the relevance of maths to their everyday lives. This helps students to make sense of the subject and understand it as he speaks metaphorically to say students can put on their mathematical glasses when completing an activity like this to view the world through a mathematical lens. Just to recap on the activities we have seen, to explain how they've linked to the syllabus, the hands-on activities of matchsticks, M&Ms and the pattern-shaped blocks all address the syllabus outcomes of MA3 8NA and MA2 8NA. The working mathematically outcomes that will be addressed are addressed through the balloon pop game, which also incorporates technology, and the hundreds chart puzzles and games and print-off sheets and all the other activities that are involved with the hundreds chart. In reference to the UDL and 3 circles, each activity I have included meets the needs of all students as they can easily be adapted to be easier or harder, especially for gearing up to stage 2 from stage 3 and vice versa. Technology is included that can be adapted to the levels of student learning. The topic is introduced using technology to gain student attention, which incorporates visuals, demonstrations and concrete materials, which can be moved into pictorial materials. Students can have choices when completing work in the way that they choose to answer questions, such as with the matchsticks activity. They can create their own shape and create the pictorial how they wish, then have the option of using either paper or technology to engage in abstract part of the activity. With technology and games chosen to use within the prop box, sound is to be minimal noise and students are told exactly where to find the games. Students have a choice of many mathematical pattern-centered games by using the websites Shepherd Software and Math Playground, which are located in my reference list. These games' difficulties levels can be adjusted to harder or easier depending on the student and depending on the grade level or stage level. Students have a chance to demonstrate different ways of showing what they have learned through the choice of either handwritten or technology, then printed of the technological work. Each activity has presented either number or geometric patterns to students in a number of ways, which allows students to present their data and understanding in a number of different ways. The graphic organiser of tables within the abstract part of the activities will demonstrate to students their level of understanding and encourage them to continue learning about patterns.